Hey everyone. So just going to go over quickly about what we talked about with the charges and subscripts today. And so I know that in my first period class, didn't necessarily get a chance to go through it with everybody. So this is there just to help you anytime you need to just refer back to this, since it is going to be such a big thing that we're going to be doing in chemistry here. Okay, so I'm going to go through and do aluminum and oxygen. So when we're looking at aluminum, we know that aluminum is going to have 3 valence electrons. And we can see that because it's in the third column of our periodic table, or the third group. So as we're looking at that, it's over here in the third column. So the column tells us how many valence electrons it has, and this one's going to have 3. Oxygen is in our 6th column, so that's going to have 6 valence electrons. So when you're first just drawing these, if you're just starting out with the elements, then you're kind of going on and adding the different types of elements depending on how many electrons are left or how many still need to be paired. If we are looking at aluminum's going to be more likely to give those electrons just because there's 3 of them, and so it's a lot easier to give 3 than to try and get the 5 that it would need in order to fill up its valence shell. In the same way, oxygen here is going to be more likely to gain 2 just because it's a lot easier to gain 2 than to try and lose all 6. So we have an element that wants to get rid of its electrons and an element that wants to gain the electrons. So as we did before, we're just making sure that we're moving this, and we're going to be taking any of these electrons from the one that's giving, and we're going to be pairing them up with some of those lone electrons on the one that's going to be taking. So these electrons are going to be moving over here for oxygen to fill them up. However, we still have this electron that has no place to go. So since there's no place to go, we've got to add on another oxygen, since oxygen is the one that is able to take electrons. And then this electron can now go over and bond with oxygen. However, at this point, we still have like an empty spot here for oxygen. So oxygen's missing an electron, which means we need to add one of the other elements that is giving electrons. And in this case, it's aluminum. And so this aluminum is going to be going and bonding with this oxygen. And we're in the same situation as before, where still we've got these 2 aluminums that have no place to be bonded with. So we're going to take these oxygens. I'm just going to actually leave the solo ones a little bit of an easier spot for me to draw my arrows. So this one can go over here to this oxygen, and this one can go and bond with this electron. So what we end up seeing instead is that we've got 2 aluminums that have each lost 3 electrons. So since they've lost 3 electrons, before they would have had 13 protons, and so those are positive, and 13 electrons, and they would have had no charge. However, now, since they have lost some electrons, they're always going to have the same number of protons, but now they only have 2 electrons, so they have a charge of positive 3. So each of these aluminums has a charge of positive 3. For oxygen, so our oxygens have actually taken those electrons and they've been able to fill up their valence shells with them. So I'm just going to draw in my electrons here for my oxygen, so my original electrons, and there I've got, here's 2 from that first aluminum, here's another one from the first aluminum, 1 from the second aluminum, and then another 2 from the second aluminum. So we can see that oxygen has a full valence shell. Originally, the number of protons it had was 8, and the number of electrons would have been 8, and so overall the charge would have been 0. However, now the number of protons are still 8, and the number of electrons are now actually 10. So it's got 10 negatives. And so that means that each oxygen is going to have a charge of negative 2. So I'm going to put that down here. I also just like to write it with the sign behind, because here I'm saying that there's 3 more positives than negatives. So I lost 3, and that makes it positive. And then here I'm saying that there's 2 more negatives, which makes it negative. Keep in mind always that the charge is going to be equal to however many electrons you gain or lose. So, in my formula, for aluminum and oxygen to bond together, I need to have 2 aluminums and 3 oxygens for all of those electrons to have some place to go, and for there to be enough room for all of those to accept the electrons. So there's a lot easier way than us drawing the Lewis dot diagrams. If we go back to aluminum and oxygen, and as long as we can look at the chart, at the periodic table, to be able to remember how we do charges, in this first column, because they all have 1 valence electron, and it's easier for them to gain 1 than lose 7, then they're all going to have a charge of +2. For the same reasons, here, it's easier to lose 2 electrons than to gain 6. These are going to lose 2 electrons, and I'll have a charge of +2. This will be +3, and then here we have +4. Now, since it's 4, it could either lose electrons or gain electrons, so this same column is also potentially -4. And here we start to count down. So -3, -2, -1. And this is going to be 0 just because there's no charge. They're all complete, so they're not going to bother doing anything. They are in retirement. So if we notice the patterns here, starting from the group 1, we have +1, +2, +3, +4. So we count up with our positives, and then once we hit 4, we kind of double count that group and start counting down in negatives. So -4, -3, -2, -1. So if we can just remember those rules when it comes to what the charges are, looking at our chart, we can see that aluminum is in the 3rd group, and so it's going to have a charge of +3. And oxygen is in the 6th group, so that's going to have a charge of -2. If you happen to look at the subscripts here and the charges, hopefully you realize that this 2 looks a little bit like that one, and this 3 looks a little bit like that one. And this is not a mistake. So when we start with our charges and we're trying to figure out our formula, all we have to do is take this, and we're going to do something called cross down. So we take our charges and we move them to the bottom of the other element that they're not already connected to. That would mean that aluminum, we would move that 2 to the bottom there, and for oxygen, we move that 3. Now what this is saying is that we need 2 aluminums for every 3 oxygens to balance out all of our electrons. One way that you can double check that, so we saw that up here with all of our drawings, so that shows why it is that that works. Another way you can double check is by taking a look to see how many electrons are being given and how many electrons are being taken. So here we've got 2 aluminums. Each aluminum is going to be giving 3 electrons away, so it'll be positive. And we also have 3 oxygens, and each oxygen is going to be taking 2 electrons, so that's going to be negative. So in total, these 2 aluminums have 6 electrons to give, and in total, these 2 oxygens have 6 electrons to take. So overall, there are no electrons that are missing from some kind of bond. They all have some place to go. And this is a nice little way to check, just to make sure that you've got your subscripts correct. So here, we always do a cross down, where we move that charge over to the bottom of the other element, and we get rid of the plus or the minus simply because you cannot have a negative atom. It either is there or it isn't. So we're just looking at whole numbers once we move it to the bottom. Hopefully that is a good little recap or a review of some of the things that we talked about today. And please make sure that you practice this. Oh, I'm actually going to add on one more before we wrap up. You might see something like magnesium, which has a charge of 2+, and carbon, which would have a charge of 4-. And if we cross those down, then we end up with Mg4C2. Now, anytime you have something that's in a ratio, so this is 4 magnesiums for every 2 carbons, if you can make that ratio a little bit smaller, then divide it by the common number. So both of these numbers we can divide by 2, which means that the number of magnesiums I have is 4 divided by 2, or 2. And the number of carbons I have is 2 divided by 2, or 1. So however many, for every 1 carbon I have, I need 2 magnesiums. And hopefully that makes sense, because carbon can take 4 electrons and each magnesium can give 4 electrons. So here we've got 2. It's able to give 2 electrons. And here we just have something that is able to take 4 electrons. 4 minus 4. And we have a spot for all of our electrons again. Okay, so hope that video will help. Just go over that concept and let me know if you have any further questions.